Hey everyone, welcome back. I'm excited to start a new series today building another classic type of game in Unity, the rail shooter. Unlike many rail shooters you may have seen in the past, we are going to use Unity splines in several unique and interesting ways. This first video is all about getting our first and main spline set up for the player and building a player controller to work with it. I'm going to build in double tap with the Unity's new input system and add a barrel roll as well. Okay, that's enough of a preview. There's lots of ground to cover today, so hit that like button and let's get started with the project. Okay guys, very quickly I'm just going to go over some initial project setup. I've started a new URP project in Unity 2022 and I've created a few basic scripts. If I go over to project settings here in the editor, I've set my namespace to be rail shooter. Over in player, if you want, you can set your company name and the project name if you haven't already. I'm going to open up build settings and I'm going to just dock it for 1 second here and drag my initial scene in there. I'm going to quickly talk about packages I've already brought in. I'll be talking about each of these as they're used. If you'd like to see a video on how to bring in all your project dependencies and assets in one click without having to install them one by one, let me know in the comments. This first one is an open source library written by Kyle Banks and allows us to get component references using onValidate. You'll see this in use in a moment. Next, we have another open source library that allows us to reference scenes in our scripts. And then I've added the new input system, the Unity Spline package, TextMesh Pro, and I'm going to import one more that I forgot about, this DoTween. I have the free and pro versions here. Either one is fine for this project. Once you've installed it, click the green button and just go with the default setup. Now, one more thing that I brought in is from PolyPerfect, their low poly ultimate pack. I'm just going to use one of their demo scenes so that I don't have to go through a whole bunch of terrain generation and whatnot to make our first initial level just to get our core mechanics working here. So I'm just going to put that under a game object called environment and leave it alone for now. The next thing to do is start with our player. So just make an empty game object here. And underneath, I'm just going to start with a basic model. We're going to bring in a spaceship in a little bit, but for now we can just use a cube. So I'll just bring it up above the world here and let's just resize it so we have a good idea what direction it's always facing in. Maybe I'll make it a little bit of a rectangle. And let's see here. Maybe we'll put something on the front so we know which way it's facing all the time. We're going to have this thing running around on a spline in a second. So I'll just call this front and let's make it a cube, but we can just spin it around a little bit so we have a little point. There we go. I'll just turn it about 45 degrees and maybe we can drag it back here a little bit and maybe shorten it up a little just so it looks like the nose of a ship, I guess. Let's bring that up a little bit. I guess it should be about 1.5 really. There we go. I'm just going to lock all these, the environment, the lights and the camera, just so I'm not clicking on them by accident. And let's add the player input component. All right, you can click create actions. I'm going to make a new folder under my project folder. Just call it settings. And I'll call this file player input actions. And let's change the behavior to invoke C# events. Now, I had already made two empty scripts here, PlayerController and InputReader. Just going to drag those on. We're going to start working on those in a moment. But before we do that, let's set up a spline. So if you recall from our shoot 'em up game, we need a spline animate component on here. So the spline animate is going to follow around on a spline. The default settings, probably okay. We'll get it running on the spline and then make any adjustments. I have a feeling that we're going to have to change the speed of it. So next, let's set up our spline. So I'm just going to call it player path. What I think is the easiest thing to do is get a top-down view and click the little box in the middle of the gizmo and you'll get orthogonal view. And then if you double-click the environment or your terrain or whatever, you'll be able to zoom right out to it. And now if we add a spline component to our player path, we can start drawing our splines. Now, I'm just going to draw a really simple path right around my little map and Okay, let's come out of orthogonal view again. And I'm going to click on the y-axis because I want to see this from the side. And the spline is just a little bit too low. Let's put it up above the world a little bit. Let's try 5. And I'm going to drag that player path into the player. And I'm going to drag the camera behind the player just so we can see what's going on. Okay, yeah, as I thought, that was way too fast. Let's just pause that and have a think here. Let's change this from running on time and change the speed way down. Let's try a 5 and just see what happens. Okay, that's, yeah, cruising speed. There we go. 50 is a little more reasonable. So it seems like we're a little bit low, a little close to the water maybe. Of course, we can adjust all the points on the spline, but I'm going to move the entire thing up to 10 for now. And then let's make those changes that I made while the editor was paused. So we're going to change our method from time to speed. And I think I'll go with about a 60, I think. Now, we want the player to be able to move in have some direction in X and Y while they're following the spline. So what we really need to do is have the player follow another object which is actually traveling on the spline. So I'm going to call that player follow. And I'm just going to take the spline animate and drag that onto the player follow component. Now the player follow will run along the spline, and we're going to have to write some code so that our player follows the player follow. Okay, let's start with the InputReader class. The first thing I'm going to do is import the Unity input system, and I'm going to make sure that we always have a player input component in here with require component. And then let's have a reference for our player input. Let's also have a reference to our move action. I'm just going to call that move action, but I'm going to expose the value of it as a public property called move, simply by reading the value of that vector2 and returning it. Then we need an awake method. Let Copilot complete that. I want to use Kyle Banks' open source library here to get references to components in the onValidate method. In onValidate, we need to call the thisValidateRefs method. You'll notice Ryder has added the using statement to the top of the class now. Then we can add the serialized ref and the new self attribute to our player input variable declaration. Let's shorten this up to an expression body method. And now we can just remove the call to get component in awake. Let's see how that looks in the inspector. So now we have the reference and it cannot be changed, in the inspector at least. We'll be using this more later. Another thing you can do with this library is inherit from validated mono behavior if you want to omit the onValidate method. So this library does more than just make your code tidier. It also has a huge impact when loading scenes where you have many components that are all trying to get component or get component in children in the awake or start methods, since the values will all be serialized already. So the repository has good documentation. There's a link in the description. We'll keep using it for the rest of the project. Okay, the first thing I'm going to do is make this a validated mono behavior so that we can just grab our input reader that way. And then let's start adding some fields for all the things we're going to need. So first of all, we're always going to need the follow target. And we should have a distance, how far behind it we want to be. And what else do we need here? We need to limit how far the player can move away from the target. Let's just have a basic vector in here. I think 2, that's fine for now. And how fast we want the player to be able to move away from the follow target, up and down and side to side. Probably want some time, how fast it will smooth back. And if we're going to make a smooth damp, we need to keep track of velocity all the time. So let's just have a private field for that. So in update, I'm just going to add comments to everything here as I go. So we're going to calculate the target position based on the follow distance and the target's position. So to do that, let's make a new vector3 for our target position. I'm going to see if Copilot will fill this out properly. Yeah, that's correct. So we want the follow target position plus the follow target forward multiplied by the negative follow distance. Then we're going to apply a smooth damp to the player's position. And now we're going to calculate the new local position. We're going to use the transform inverse transform point. And what that does is converts a world position to a local position. Once we've got that local position, now we want to apply the user input to it. So we've got our input move property. We can just multiply it by our other variables that we've already set. Now let's make sure that we clamp it to the range, minus and plus for the minimum and maximums. And then we just update the player position. And all we need to do then is reload and drag the player follow transform into the component. And just for interest's sake, let's add a little sphere here, just so we can see what we're following around. Okay. So it's working. We can move around within range, but as you can see, we're not actually facing the follow target yet. So we've got to deal with rotation. Let's stop this and go back into our code. So to handle this, the first thing that we can do is let's just match the rotation to the rotation of the follow target. But it would be really cool if we could actually lean the plane a little bit as we're moving around. So let's set a max roll and a speed at which to roll. It can be pretty low, I think. And then we're going to have to keep track of the roll too. And I think for this, we can just do a lerp, but let's just add a comment here. So we'll set the roll to be a math lerp of the original roll plus whatever we're moving, which is just going to be a +1 or -1, multiplied by the max roll time, but multiplied by the roll speed. And then let's just set a new quaternion to the transform rotation using our original X and Y, but use the roll as our Z value. So let's see how that looks now. So now we can lean the entire player. You see it moves the camera too, and I kind of like that actually. But you could move the camera out and have its own follow. It could have its own follow code, I guess. But this looks kind of cool actually. Gets a little tight on the curves. And maybe I'll drop the camera down a little bit. I can worry about that later. I just want to extend the range a little bit, and I'm going to think about this for a minute, but I think I'll just rename this movement range, and I'll call this the movement limit, because that makes more sense for what we're going to use that for. And let's make a new variable here. We maybe don't even need an additional one, but I'll just do it for now. I want to multiply our movement that we're applying to the local position by even more. Technically, that's not really that much different than the movement speed, but we'll just keep them separate for now. So now we get a much jumpier and go a little bit further. This might need some tweaking in future episodes. We'll see how things come along with the firing mechanisms and everything. But that is working for now. So let's bring in a real model. So I'm just going to grab the spaceship that was free. I have all the models in here now. I'm going to use some for enemies later, but let's find the Star Sparrow. I think this first one's probably okay. And just drag that under the player. And it's a little bit bigger than our original model, but I think it's okay. What we can do is disable the boxes that I made before. And if we look at the camera here, we're very close. Let's back the camera off to about a -22. Yeah, that looks pretty good. It's definitely working as intended. So I think one more thing that we could add that would make this really cool is a barrel roll. Barrel rolls are very common in rail shooter kind of games. But to do that, we need to be able to handle a double tap, and that's going to be a little tricky. So let's go back to our input reader component. So first of all, let's keep track of the amount of time we require between taps. And I think I can be pretty lenient with that to start with. So 500 milliseconds should do. And let's keep track of the last time the move action was pressed and what direction it was pressed in. So then what I'm going to do is on enable, we're going to register for the performed action. And on disable, we will deregister. And we'll make a method that will be fired anytime that happens. So that's when the player input fires off a C# event because the player actually clicked a key. So let's define our method there. And we're going to define 2 C# actions here to then fire off and let other components know what's going on. So in our onMovePerformed method, what we're going to do is, let's first of all get our direction. I think we can use mathf.sign. Let's try that out. Copilot's making a suggestion here, but it's not really what I want. Sometimes you just have to look and see what it's trying to do and evaluate for yourself whether or not it's correct. This is what I want, however. Or if the current time minus the last move time is less than the double tap time, and the current direction equals our last move direction, so it means we're tapping in the same direction, then we're going to fire off either one of the events. So if the player was double tapping to the left, we'll fire that event. If it was to the right, we'll fire that event. And then in our player controller, we need to register for these events. So let's do that in Awake. So because we made those C# actions public, we can just register for them straight off of the input reader. Now, let's start with the on left tap. What I'm going to do is, first of all, if we're not currently tweening something, and we're going to need a reference to our player model, but then we can run the do local rotate on the player model. Now, I'm going to look at the suggestion here. I don't think it's kind of okay, but we're going to have to tweak it a little bit. Let's get a reference to the player model and fix that method name. Okay, now let's just break this down so it's easier to read. First of all, we don't need an on complete necessarily. An ease will do enough. Let's just make the duration a little bit longer for now. We need to change the rotate mode to not be the default. We want it to be a local. I'm going to put this into its own method because we can reuse it. Let's just call it barrel roll and let it take it in a direction. So instead of here, let's just put 360 degrees multiplied by our direction. And that way, on the left tap, we don't need to pass in anything because we already have a default of -1. But on the right tap, let's pass in a 1. Format this up just so it's a little bit smaller. Now, anytime you register for events, it's good practice to deregister for them. So if I'm doing Awake, I'll do it on destroy. And I like to put that at the bottom generally. And let's just move all these kind of helper methods to the bottom. Clean that up. So now we just have to drag our model in. That should be all we need. It's a pretty fast spin, but it's definitely doing what I want. I am noticing one problem though. If I double tap up or down, it's registering that. So that's probably a problem with our math f.sign, which I suspect is not returning 0 when it's actually a 0 input. In fact, I'm almost certain. So let's stop this and go and have a look. So first of all, let's change this to be explicitly right or left. So to do that, let's in the else condition, let's change it to current direction must be greater than 0. So that'll solve part of the problem anyways. We still have to make sure that we're actually getting a 0. So to do that, let's just get rid of this. And let's just try it out and make sure that it works though. Yep, up and down, no problems. Okay, problem solved. One more thing that I want to take care of here is we shouldn't have a hard-coded value here for the duration. We should be able to change it in the inspector. So let's make it into a variable. Let's call it roll duration and make it a little bit longer than it was. A nice smooth roll. With the do tween easing, it should look pretty nice. Yeah, that looks pretty good actually. Okay, well I guess that's about enough for the first video here. Looking pretty good so far. Lots of features still to implement, lots of programming patterns we're going to be using. We're going to be getting into object pooling. We're going to build an advanced state machine during the course of this project. I don't know if you're ready to move beyond the enum state machine. This project will have you covered. Yeah, so that's about it. Thanks for watching. Make sure you subscribe if you're interested in seeing the rest of the series. And I'll see you in the comments below.